Okay, so welcome to the last lecture. We will be finishing off 4.2, and then we will be going to 4.3. 4.3 is pretty quick. So last time we learned how to find the solutions to a 3 by 3 system. The whole thing being you want to choose one variable that you want to eliminate from all of the equations using what I call the eliminator equation. And then from there, you can get a baby 2 by 2 system, which you can solve, and then use that in any of the three equations to solve for the last variable. So with this one right here, what would be the perfect variable to eliminate? Well, X would be a great choice because you have this problem, you have this one right here. I also learned that I can add a tail to my laser pointer. And so I was just thinking maybe in the future when I teach the classes, I can just write it and have it fade away before people can write it. It's like, okay, we've got the eliminator is E1 and we're eliminating Z. So we have 3x plus, can you guys write fast enough? No, I'm kidding. But anyways, so X is great because this has a leading coefficient of 1, and that makes it a perfect candidate for just multiplying one equation to get rid of things. However, I would argue that there's an actual better choice, which is Z, because the bottom equation already has Z removed from it. And furthermore, the sign difference on the one where you will need to remove the Z from it, they already have opposite signs. So that's a perfect candidate. So I'm going to do that, but there's nothing wrong with choosing a different variable. As long as you're consistent, it might take a little longer, but it will still get you there in the end. So I'm going to eliminate Z, and I'm going to I forgot to label these ones E1, E2, and E3. I'm going to make E2 my eliminator. So first I'll do E1 and E2. And so we've got 3x plus 9y plus 6z is equal to 3. And then 2x plus y minus z is equal to 2. One thing, just a small thing of note, is that notice that everything in the first equation is divisible by 3. Remember that all the old algebra that we've learned is still viable. If you wanted to, you could divide all the terms of that one by 3, and it would make it a little bit simpler. It's not going to help too much, but it can do something for you. But regardless, we need to multiply the bottom equation by 6 to make us have a negative 6z down below so that the 6z and the negative 6z cancel out.
Well, why'd you use the six?
So I'm trying to make sure that these two z terms have the exact same coefficient but opposite signs. They already have opposite signs, but I need them to have the same number too.
Because right now we're trying to solve for this.
We're trying to eliminate z.
Yeah.
Yes, exactly right. So we've got 3x plus 9y plus 6z equals 3. And then now it's going to be 6x plus 6y minus 6z. Oh, no, 12. 12x. 12x. What am I doing? 12x plus 6y minus 6z is equal to 12. As a small aside, I have had students do this in the past. When they multiply, they just write it above it. They write 12x plus 6y minus 6z is equal to 12. And that's fine if that's what you want to do. My only hesitation is that I start to get, like myself personally, I get confused with all three equations there. It kind of gets a little sloppy to me. So that's why I avoid doing it. But if that makes sense to you, go right ahead. Regardless, we can now add these two equations together, and the z's cancel. 3x plus 12x, that's 15x. 9y plus 6y, that's 15y. And 3 plus 12, that's 15. That's neato.
15, 15, 15.
15, 15, 15. You could, if you want to make this easier on yourself, you could divide this entire equation by 15. That will make the numbers much smaller and easier to work with. And that is completely valid to do because remember, multiplying or dividing by a non-zero number will always keep the same solution set. So the solution set to 15x plus 15y equals 15 is the same thing as x plus y equals 1. So you can do that if you want, but I'm not expecting us to be that clever on an exam, so we'll just leave it as is, though you can do that. Sure. So actually, do we have any preference? Are we okay doing that? Sure. We can divide both sides of this equation by 15 because all terms divisible by 15. And that will give us x plus y equals 1. So that's the equation we get when we eliminate the variables c from E1 and E2. And our eliminator is E2, so now we're going to use E2 on E3, but we notice something. E2 and E3, z is already eliminated from E3. So we have x plus 5y is equal to 1. We didn't need to do anything. That's the reason why I decided to use that's the reason why I decided to eliminate z, because I didn't need to do it too much. I already had one of them that had it removed. Now, on an exam, by the way, please remember that you don't need to write that stuff. You can just write the x plus y equals 1 and then stack right underneath it the x plus 5y equals 1 and solve that. That is totally fine to do. This is just for our notes to see what we are recognizing. So we've got this baby system, which is x plus y equals 1 and x plus 5y equals 1. Now, it doesn't matter which one you decide to do. I would argue that x is an easier choice to eliminate, though this is also a perfect candidate for it's called substitution. You could use substitution here and it wouldn't be too terrible to work with. Personally, I'm going to multiply by -1 to eliminate because I prefer the elimination method. And it doesn't matter which one you decided to use to multiply by -1. Just as long as one of them has a positive 1x and one of them has a negative 1x, we're all happy. So this gives us negative x minus y equals -1, and x plus 5y is equal to positive 1. Now that they have the same number but opposite signs, we'll add them together, canceling the x's. Negative y plus 5y is 4y. -1 plus 1 is 0, which gives us y is equal to 0. That is okay. It's totally fine for one of your variables, or even, hell, even all of your variables to be 0. That can happen. It's rare, but it does happen where all of them are 0. And so don't let this be the scary portion. Like, don't get a 0 and say, oh, that I must have done something wrong. Getting 0 is okay. Getting really, really nasty fractions, that's a cause for concern, as we'll see in another example pretty shortly. Yes.
So in the same fashion that you made where the purple is,
Mhm.
where it's the 15x plus 15y divided by 15, in the same way that became 1. If you did that to like in the beginning where it was the 3x plus 9y and then divided it all by 3,
Mhm.
would you still have the 1 on the end? Because I thought that it'd be a 0.
So if you divided this entire equation by 3, you'd get x plus 3y plus 2z is equal to 1, because 3 divided by 3 would be 1. So, and that will actually simplify things a lot, and it'll make it a little easier to work with everything else. So that is an option, but I just wasn't usually speaking, I try to make sure that we I didn't want to erase all that. I just want to erase that and that. I try to make sure that I'm doing it in a way that would be more presentable for how we would see it on an exam. Because when you're looking at it on an exam, you're trying to solve it as quick as possible. You're trying to recall all that information. You're not necessarily saying, oh, that's cute. That's divisible by 3. You're not really thinking about that too much. If you are, awesome. Kudos, but it's not required. So now we can use either one of the equations, x plus y equals 1 or x plus 5y equals 1, to solve for x. It's going to be a pretty quick calculation. I'm going to use I'm going to use this equation up here because that one's a lot nicer. It's not, I mean, it's not really even going to make much of a difference, but regardless. So x plus 0 equals 1. That gives me x equals 1. Then I can use basically, I can't use equation 3 to solve for z because equation 3 doesn't have any z's to solve for. And the convention is to use your eliminator, so in this case E2, to find your other variable, but there's nothing stopping you from using E1. But I'm going to use E2. So 2 times 1, and then y plus y, so plus 0 minus z is equal to 2. Yeah. And that's 2 minus z is equal to 2. That gives me negative z is equal to 0. That gives me z is equal to 0. So our answer is going to be an ordered triple, x, y, z. That's just to remind myself to find the variables in the proper, like to write the variables in the proper order. So 1, 0, 0. And I will admit, if this was me on an exam, I'd feel a little bit like that's too easy of that's too nice of an answer. That like, why isn't it like 1, negative 3, 5? And so I would go ahead and just quickly in my head check it. So 3 times 1 is 3 plus 0 plus 0. Does that equal 3? Yes, it does. 2 times 1 plus 0 plus 0. Does that equal 2? Yes, it does. 1 plus 0, nothing to plug in. Does that equal 1? Yes, it does. And so I would be able to check it. And with these ones, by the way, the nice thing is to check them. You really all you need to do, because they already have all the numbers on the right-hand side, there's nothing that you need to plug in on the right-hand side. So with your calculator, all you need to do is plug in your x, y, and z and make sure that it equals the number on the right. That's the nice nifty thing. So 1, 0, 0, despite it looking weird at first, is the actual answer. Yes, Eric.
If someone's on an exam, we don't write it like that, that's only like a point off, right?
No, that is a situation. This is me making sure that you understand that it is a coordinate point in 3 space, but I've had plenty of students, and in fact, even teachers will write this sometimes. They'll just write x equals 1, y equals 0, z equals 0. Or they'll do this. And that's fine with me. You don't have to make that, like, you don't have to do that. That is more like this aspect here. That's me trying to prepare you guys a little bit for Math 253, which is linear algebra, which is like linear algebra is really studying I mean, if you're doing it right, which my teacher didn't do it right, linear algebra is meant to be a visual learning process. So there's a lot of if you're allowed to, and especially if you plan on taking that course, if you plan on taking linear algebra at any point, which you will need to take if you ever go into computer science or engineering at all, you're probably going to need to take a linear algebra course. I think I've mentioned him before. Yeah, I have a math crush on him. 3 blue, 1 brown. A math crush. Like this guy is I would love to meet him. He is brilliant. He has an entire video series on linear algebra, and he's able to show you the visualization of a lot of the machinery that we use in linear algebra, and it's great. So if you need to take linear algebra, please watch his videos on it because it'll give you so much more intuition as to what you are actually doing. He has a great video on a thing called the dot product. And the determinant of a matrix, and those things are something that we learn the machinery for, but it feels very like when I learned it, it felt very, very much like learning the multiplication algorithm. Remember that whole nasty thing where it's like 12 times 13. You gotta, okay, 3 times 2 is 6. We write a 6 here, and then 3 times 1 is like that whole thing. It's very, very mechanical. There's not much intuition as to what you're doing. Like this is the thing that I try to explain to people when they tell me that they dislike new math, and I tell them you don't dislike new math, you just don't like learning a new thing. The new math is far more efficient at showing students what is useful. And so I don't need to go down that pathway. If you want to know more about new math, I'm happy to talk to you about it and why it is a good thing. But anyways,
Is that the thing that Mr. Incredible is getting at?
yes. Math is math. Yes, it's true. Math is always true. That's 100% correct. But how we teach it can change, just like any subject. And so it's a great trope in Incredibles 2. I love that part of the movie. It was hilarious. But it is I think it's just mainly meant to be a nod to parents at their frustrations, which are valid because it's not very like sadly there's a disconnect between the parent and the teacher and the kid, and they're trying to like you're playing telephone with your child when you're doing that, and it's really bad. But anyways, I'm getting sidetracked. So onwards. Once again, if you're taking linear algebra, in fact, if you ever want to watch any cool video on mathematics, this guy does some great videos. Next one. So sometimes they will show up like this, whether you're taking math 126 and you're taking on Alex, or if you're using MyLab or MyMath, whatever it's called, or Cengage, or even in textbooks and stuff like that, they will sometimes put the system of equations like this. And it always bugs me because it makes everything look really awkward. So remember that you can add 0 to anything, right? You can add 0, it doesn't change anything. So we can rewrite this a little nicer and write this as 2x, and we can leave a space, or you can write a plus 0y if you want to. I'm just going to leave it blank, but it's okay to do that. And then plus z equals -5, and then 3x plus y equals -10, and then 3y minus 4z is equal to -6. That makes it look a lot more approachable, and it lays out what you need to do far better, in my opinion. So if it helps you out, definitely feel free to write the plus 0y, the plus 0z, and the plus 0 or the 0x here. That's okay to do. Not wrong to do. I'm just going to ignore it. So when we're looking at this problem, we got to decide what variable we want to eliminate. And there are better choices than others. I would argue that C is the best choice to eliminate, but not by a very slim margin. Y is basically just as good to eliminate. Or X I would not eliminate because the two X terms have different numbers, which will mean that I'll have to multiply two equations, which opens me up to more chances for making a small arithmetic error. So I'm okay either removing Z or Y. Which would you guys prefer? Why? Why? Hilarious.
It's cute.
I'm with it. I'm with it. So we're going to eliminate Y. And in that case, the best choice for your eliminator is E2, which I forgot to label them. Here's E1, E2, and E3. And I've mentioned several times about this concept, but like you don't have to be as systematic as I am being. If you want to just stack them on top of each other and work through it, that is fine. I just like to work in a very systematic way. So our eliminator is E2, so we're going to try and eliminate it from E1. E1 and E2, but there's no need. Y is already eliminated from E1. So we have 2x plus z is equal to -5. So that one's already done for us. Now we'll go on to E2 and E3. You're using your eliminator, E2 on E3. So E2 and E3. Stack them on top of each other with the spaces. So E2 is 3x plus y, space equals -10. And then 3y minus 4z equals -6. And I know that does look weird at first, but remember, that's just a 0z and a 0x in those places. So when you eliminate y, it'll become an equation in terms of x and z, as we'll see in just a moment. So we'll multiply the top equation by what number to get rid of y? -3, -3. Because we want them to have opposite signs.
Oh, yeah, so. And since we have the same line. So. But why -3?
So we want them to have the same number, which they don't right now. So what do I need to multiply y by to get 3? -3. But then yeah, as you said, I need to have opposite signs so that when I add them together, they cancel. So we've got -9x minus 3y equals positive 30. And 3y minus 4z is equal to -6. And I'll add them together. The 3y's in the middle will cancel. -9x has nothing to add to it, so it just stays -9x. -4z, there's nothing for -4z to be added to, so it just becomes -4z. And 30 plus -6, that's positive 24. And there we have it. We will now have our system, our baby 2x2 system. Any questions so far?
So we're spacing them.
Like we're putting spaces. Yeah, just to make it line up, kind of like what we did with long division. Remember when we didn't have a power of x, we put a placeholder so that everything kind of lined up nicely. So it was like all the like. So if I just as an aside, if I had to do x squared plus 1 divided into x to the 5th plus x cubed minus 1. Remember how we put an x to the 4th, a 0x to the 4th, a 0x squared, and a 0x? In the same fashion, just to get it to look nice and be more workable. So, all right. And then we'll stack those two baby systems on top of each other. So 2x plus z is equal to -5, and -9x minus 4z is equal to positive 24. And so I'd like you guys to go ahead and solve it from here. Go ahead and find the x, find the z, and then find the y. I will slowly fill in details. So people watching the recording, go ahead and pause it and start working through it. This is the solution to the 2x2 system, and then we'll work on the next part of it. All right. So we should get the answer -4, 2, and 3. So once we had the baby system, I chose to eliminate z, but you could have also used substitution if you'd like. Substitution is completely valid. But I chose to do elimination because I already had a 1z and I had a -4z, so they already had opposite signs. So I just need to multiply by 4. I'll get that -x is equal to 4, so x is equal to -4. And then I decided to plug it into the first equation of the baby system. It wouldn't be wrong to use the bottom one, but the top one's easier to work with. So I get -8 plus z is equal to -5, so z is equal to 3. And then we kind of have an interesting choice. So we're trying to solve for the last variable, which is y. And you can't solve for y in the first equation. There's no y to solve. So you can either use the second equation and plug in your x value to solve for y, or you can use the bottom equation and you use your z value to solve for y. No matter what you do, it'll still give the same answer because it has to solve all 3 of the equations. I just decided to use the middle one, and that gave me that y was equal to 2. Any questions on that? Okay. Oh, yes.
Could you just do a recap of why you chose those ones? I know you said that they were the easiest.
Uh-huh.
Like what made them the easiest for you then?
In the very, very beginning, so looking at this one right here, I chose z because I already saw that the signs on the z terms were opposite. We got a plus and we got a minus. And this z term has a coefficient of 1. So It's not like trying to figure out exactly what to do. So for example, with the with x's, with the x's, I need to figure out the least common multiple of 2 and 3, which isn't too terrible, right? It's not, it's 6. So I just need to multiply the top equation by -3 and the bottom equation by +2, and it'll all be good. But over time, I've realized that this is the better option. Whenever you have a coefficient of 1, try to use it to your advantage. That the y was just as good because it was a 1y here, but the only difference being that this one had a +3, so it wasn't opposite signs, so I needed to multiply by a negative. And knowing myself and knowing how many times I've done this, I've accidentally forgot to distribute a negative sign into everything. Like I'll multiply the left-hand side by -3, but I'll only multiply the right-hand side by +3 just because I'm not thinking properly, and it makes me mess up. So that's just me from my experience. Now that might not happen to you guys. You guys might be better than I am at it. So it's fine if that's the case. So that's my idea in a nutshell. That's why I chose that I was thinking Z would be the best option. That being said, please understand that you will get the same answer no matter what. As long as you do the correct arithmetic, the answer will still be the same.
Choose it.
Exactly right. And when you're first learning, that's kind of the point, right? You're not going to be perfect at doing it the first time around. Nobody is. And it's just with time, you start to realize what is beneficial, like what's faster. Just like a kid learning how to walk, right? You realize that you can't really walk and hold a juice at the same time, or a pouch, a juice pouch. And just remember my son asking for juice, like he wouldn't finish it, wouldn't finish a juice pouch, and would throw it away. And I was like, no, you got to finish it. What? Oh God, no! They tasted disgust. No, it was like this pouch of pureed fruit. I wasn't a big fan. Not a big fan of it, but but kids love it for whatever reason. Like we're talking like infants, like young, like under the age of 2. Anyways, I'm getting sidetracked. Looking back at this one, same idea as why I know that Z is the best choice. It's taking a second to load. There we go. Z was the better choice because I can just multiply by 4 and it's all done. If I wanted to eliminate X, I'd have to multiply the top equation by 9 and the bottom equation by 2 because the least common multiple of 2 and 9 is 18. So, all right. Now, one of the things I did want to do was this one together because I accidentally messed up when I made this problem, and the answers will not be nice. And that is like, and so we're going to do it and show you that you can have not nice numbers. However, on a final exam, if they're not nice numbers, I would be skeptical of my result. So let's go ahead and work through this one. Which one do you think should be your eliminator? There is a very, very clear choice. E1. All of its coefficients are 1. It's perfect. E1, E2, and E3. So we're going to use E1 as our eliminator. And basically, the world is our oyster. We can eliminate X, Y, or Z. It doesn't really matter. I would argue that Y is the best choice because the other two equations, their equations have a negative one. Their signs are already negative. So the opposite sign of our positive Y already. But any of them would work. Do we have a preference? Do we want to spice things up and do removing X instead? We'll remove Z. Sounds great to me. All right. So E1 and E2. We'll stack them on top of each other. So X plus Y plus Z equals -1. And E2 is 4X minus 3Y plus 2Z is equal to 16. So they already have the same sign. They're both positive. So I'm going to need to multiply my eliminator by a -2z, or sorry, just a -2, excuse me. Multiply by -2.
Wow.
And that's fine. If you want to, you'll see, like, you'll get the same answer. So you get -2x minus 2y minus 2z is equal to +2. And then you'll get 4x minus 3y plus 2z is equal to 16. We'll add those two sets together. The two z's cancel. We get 2x minus 5y is equal to 18. Right? 2x minus 5y, because negative 2y plus negative 3y, yeah. 2 plus 16 is 18. Cool. All right. And the next one, we got to do E1 and E3. So x plus y plus z equals -1. And E3 is 2x minus 2y minus 3z is equal to 5. This time, they already have opposite signs, the z term, because that's what we're eliminating. We're eliminating the same variable from each equation. But this time they have opposite signs, so I just need to multiply the top equation by 3. Yes. I heard someone say it, and that's good enough for me. So when we do that, we get 3x plus 3y plus 3z equals -3, and then 2x minus 2y minus 3z is equal to +5. And we will add these two things together. Canceling the 3z's, we've got 5x plus y is equal to 2. Any questions on those first two parts? There is, once again, a lot of arithmetic to these problems. So it is in your best interest to take these ones slow. Whenever I rewrite down the equations, I would definitely double check it when I make sure that I wrote it correctly before moving on, because making one mistake will throw all of these things off. Like even the changing of a minus to a plus will throw everything off, and it will get you something that's usually a very, very nasty number. So definitely check your work as you go through. Now we have these two equations with two unknowns. We have a baby 2x2 system. Let's stack them on top of each other. 2x minus 5y equals 18, and 5x plus y is equal to 2. I would argue that the best choice is to eliminate y, but you could also do substitution. That's fine too. But I'm going to eliminate y. So I'm going to multiply the bottom equation by +5. And that will give me 2x minus 5y equals 18. And then 25x plus 5y is equal to 10. And we'll add those two together. And the 5y's cancel. And we end up with 27x is equal to 28, leading us to x equals 28 over 27. Now, if this was me on an exam and I got this, I would be very, very skeptical of my work at this point, because that's not a nice fraction or a nice number.
Doesn't mean it's wrong.
It does, yeah, exactly right. Thomas is exactly right. It doesn't necessarily mean that it's wrong, but I would definitely, after solving the rest of it, I would definitely check all of my answers. Yeah, I check all the x, y, and z values in all three of the equations, not just one of them to see if it works. I would check it in all three. And my reminder again, when it comes to problems on the exam, if you need to come back to them, if you're uncertain of your answer and you want to check it and try it again, always try it with new paper. Don't look at your old work at all. Take it from somebody who's made that mistake plenty of times. If you keep looking back, like if you have your old work in front of you, you will want to make you will unconsciously make the same mistake. So rip that scratch paper off from the back, putting it on top, and like cover up your old work, but and look at the problem and try it again. So we're not certain. I mean, like this is the correct answer, but we're gonna put a dash next to it. Now we're coming back to it. We're looking through all of our work and it does look correct. So now we'll continue onwards. The good news is we have a calculator. So these fractions will become much less painful to work with. So it doesn't matter which one we choose. I would probably recommend the bottom one so that I don't have to solve for y at all. Like I don't have to divide or anything because there's always just a 1y, but it's not wrong to do the top one. So 5 times 28 over 27 plus y is equal to 2. 5 times 28 over 27 is 140 over 27. Good. 140 over 27 plus y is equal to 2. 2 minus that is negative 86 over 27. Now I'm starting to feel even more skeptical. Like 28 over 27 wasn't too terrible, but negative 86 over 27, that's looking even worse. So I'm still skeptical, but I'll hold my disbelief for a moment and come back to it later. Oh, I forgot to underline my x value. Now we can use any of the equations to solve for z. That being said, I would definitely recommend E1 because E1 has one coefficient each time. It's 1x plus 1y plus 1z. So that's perfect choice. And so we have 1x, so 28 over 27, plus 1y, so that's negative 86 over 27, plus z is equal to negative 1. Is that correct? Yep. So add 28 over 27 to that. So 28 over 27 minus 86 divided by 27 is negative 58 over 27 plus z is equal to negative 1. That gives me that z is equal to, when I add, so negative 1 minus my answer is 31/27.
Definitely use a calculator.
Yes, definitely. Don't you'll burn your corneas. Burn the rosin cones in your eyes if you try and deal with these fractions. They're not fun. So we're allowed a calculator, definitely use it to your advantage. So our answer is an ordered triple, x, y, z, and it's equal to x is 28/27, y is negative 86/27, and z is 31/27. All right. Now, if it's me on the exam, I solved it, but I'm very, very skeptical. So I will go back up. Don't worry if you don't have well, I mean, I'll just zoom out so we can see the whole problem. Sorry if you can't read that at the very bottom. It's 20. But what I'm going to do is in each equation, I'm just going to plug in the left-hand side. So in my calculator, 28 over 27 plus negative 86 over 27 plus 31 over 27. Does that equal a negative 1? Yes, it does. I'll check the next one. 4 times 28 over 27 minus 3 times negative 86 over 27 plus 2 times 31 over 27. And does that equal 16? Yes, it does. As long as I've checked it in 2 of them, it's probably going to work in the third. But if you want to, you can verify it further and get that final answer. Any questions on that? Yes. More?
Yeah, like,
Good. Good. Okay. So, and then just like with regular situations, there are word problems that you can do. Totally fine to do that. So, Philip, no relation to me. Not like, I mean, Strangely enough, he does like the that person spells their Philip correctly with one L, but either way. And Tad and Kendall, no relation to Philip at all. They play a total of 70 Magic the Gathering games on Monday after school. They must have been there until midnight, apparently, because a good game of Magic will last an hour, 30 minutes. Not that I know from experience, but anyways. Tad played 2 times as many matches as Philip, and Philip played 10 more matches than Kendall. How many matches did each person play? So we're reading it, we're digesting the problem, and we ask ourselves, what are we trying to find? The number of matches that each person plays. So that will be our variables. And you can use X, Y, and Z. However, I think it would make more sense to use P, T, and K just to make it very visual. So let P equal matches for Phil, T equaling matches for Tad, and K equaling the matches for Kendall. That's not how you say matches. That's mathes. And it doesn't, once again, as per usual, you don't need to write a paragraph for your variable definitions. You just need to write enough so that it's kind of clear what each variable represents.
So like total gains.
Exactly right. And that gives us our first equation. This statement right here, the fact that they played a total of 70 games of Magic, and we're assuming they're just sweeping the field. They're not playing each other. They're just trying to dominate all the young kiddos who are playing at the school as well. And then convincing them to trade them their Jester's cap for a really stupid card or Black Lotus, Get that $10,000 Magic card if you can. Is it 10,000 at this point? I don't know. Pretty close to it. It's insane. It's an insane card. It should never be printed, but regardless.
What's a Black Lotus?
It is a 0-cost artifact that you can tap and sacrifice it for 3 men of any color, which is broken incredibly. If I knew anything about the game, that would probably be broken. Anyways, so that first thing it's the fact that they play 70 games together. That tells me that if I add up the matches from Phil plus the matches of Tad plus the matches of Kendall, that'll equal a total of 70. Now, the next one always trips me up. Tad played 2 times as many matches as Phil. When I was a TA at OSU, we had this problem, essentially different verbiage, but it always ended up being blank played twice as many or 3 times as many as blank. And I had to grade this problem in the grading party. So I had to grade 300 versions of this, and that was my worst night as a TA because I always screwed this up in my head. This one always trips me up. Is this represented? Don't write this down. Is it T equals 2P or P equals 2T? Which one? 1 or 2? Which one is it? Number 1. I heard some people say 1, some people say 2. The correct answer is number 1. And it's okay if you didn't get that because that's me every single time. This one always throws me off. What I do to figure it out is I make up a hypothetical number and I figure out which one fits into that concept. So if I know that Tad plays twice as many as Philip, let's just say that Phil plays 4 games. You can choose any number you want, but let's just say Phil plays 4 games for just a second. How many games would Tad play? 2 times that. So T would be 8. Which formula makes that a true statement? This one or this one? Well, if I plug in 4 for P, 2 times 4 is 8, and T is 8, so I get 8 equals 8. That one works. But if I try here, 4 does not equal 2 times 8. 4 does not equal 16. So this is not the right choice. It's this one. So that's what I do. If I don't know which equation to use, if I'm struggling between 2 of them, I mean, sure, you could try and flip a coin. That would work if you're really desperate. But making up a hypothetical with that verbiage of that in the problem statement That will help you figure it out and narrow it down.
I just use it.
And that's great. If you are, then you're better than me. You're better than me because this one always throws me up. True story. So T is equal to 2P. The last one is this statement that Philip played 10 more matches than Kendall. So that one is quite quick. Philip's matches equals 10 more than Kendall's. So P is equal to K plus 10 or 10 plus K, however you want to write it. So this is where things get a little bit interesting because this is a situation where substitution is very, very viable. Most of the time with 3x3 systems, substitution is not viable. It's a very, very long process. However, for this one, it will work out. That being said, if you want to solve it the old-fashioned way, you can. You could rewrite this as P plus T plus K equals 70. Negative 2P plus T equals 0. And P minus K is equal to 10. And you can solve it this way. And it'll work out. 100% will be fine. Right? You could eliminate T. I'd honestly recommend eliminating K. It'd be nice and neat. But what you could also do, so that's one alternative. We could solve it this way by bringing all the variables to the left, numbers on the right. Right, so the T equals 2P. I have to subtract the 2P to bring it over to the left-hand side. So negative 2P plus T, there's no numbers, so it just equals 0. Bring the K over to the left-hand side. That's why I've got P minus K equals 10. And I can solve that. However, from here, I know that T can be written in terms of P. And because these are equal, I can write K in terms of P as well. This means that K is equal to P minus 10. So I can take this and plug that in for K, and I can take the T equals 2P and plug it in for T to get myself P plus 2P plus P minus 10 is equal to 70. I replace T with 2P because T is equal to 2P. And with the first one, I can't solve for, like, if I tried to replace P with K, I wouldn't have a nice system. There are many ways to solve it, by the way. There's many different ways to get around it. So I'm going to replace those things. And then this is going to be 4P minus 10 is equal to 70. That gives me 4P is equal to 80. So P is equal to 20 games. Not bad, not bad. So P plus 2P plus P.
I thought you were going to distribute, you know.
Then because now that we know what P is, we can solve for T and K almost immediately. So from the fact that T is equal to 2P, we have that T is equal to 2 times 20, which is 40. And from the K equals P minus 10, we have K is equal to 20 minus 10, which is 10. So just writing it neatly, P is equal to 20, T is equal to 40, and K is equal to 10. So Tad definitely played the most matches. Which is interesting. Kendall must have just brought a bad deck because Kendall's usually the best out of the three of us. Not that this would be me, but if it were.
Yeah, well, you.
Yeah.
Imagine.
I'm struggling to understand how you wrote down that Philip played 10 more matches than Kendall.
Mhm.
Because to me, it's like, it would just be like, how you wrote it initially, or how you wrote it in the yellow would make more sense than the initial one.
Oh, okay.
But I was just kind of wondering like, why did, because to me, I just would have never written it down.
You would have written it as K equals P minus 10?
Probably, probably would have messed up.
For sure.
But it makes more sense like that than it ever did at the grade.
Okay. So the way I was looking at it was I was saying Phil played 10 more matches. So Phil's matches is, which means equals, 10 more than Kendall's matches. So 10 plus Kendall is equal to P. That's how I viewed it. But you can also, as you said, if you're saying that Philip played 10 more matches than Kendall, that means that Kendall's matches would be Phil's minus 10. That's another way to view it. That is our answer. Any other questions? I'd be hard pressed to see a systems like a word problem with a system of equations on the final. That being said, it's fair game. I don't know. I still haven't seen the exam. I'm waiting until Friday to type up the exams.
Wait, so they give you, they write the exams, you just shoot.
They do write the exams, but they write them in a bad format. Their format is bad and they should feel bad. Their exams don't look good. Like they're like, oh God, if I could show you, you'd be embarrassed. Like if you take another professor for a different math class and you see their exam style, it's terrible in comparison to mine. Mine is perfect.
So like your version of like Taylor's version of her out, like
Yeah.
that 120/60 final exam, Bill's edition.
Exactly.
Yeah.
Exactly. So I will write it in the and the other reason why is that some teachers, the way they teach, so for example, with polynomials, remember how we described our end behavior as rising or falling to the left and the right. Some teachers, their textbooks that they follow, they write it like this. That's their version of saying falls left, rises right. Or like this for rises left, rises right. That's the way their textbook does it. Other people use the calculus notation, the as x goes to infinity, p of x goes to blank. So when they've written the exam, their version has whatever they chose. I believe like most of the time they use calculus notation. So I will change up the terminology and say like figure out whether it rises left or rises right.
I think turn that 10 to negative
In the orange.
in the red. No, that's sorry, not the red, the yellow. You rewrote it as K is per.
So I subtracted 10 from both sides to get K by itself. And then I just rewrote it with K on the left-hand side.
Solve this the same way we've been solving other problems, right?
Exactly right. Yes. This is me being clever of realizing that I can write all of the variables in terms of P, but that is not something that I would expect. If you don't notice that, just rewrite it in the normal format that you're comfortable with. And then decide on a variable to remove. You could either like the best choice would be K because they're already opposite signs and they're the same coefficient, same number.
In the color format, we'd have to do it in the black format.
I think so. I mean, there is a way to break it down in that way, but it's very, very it'd be more convoluted than necessary. All right. Good. All right. We'll take our first break and then we'll work on to 4.3 after this.
And that's
People watching the recording, go do some guided meditation. All right. So we will start at the last unit, last section, guys. We've gone through over 20 at this point. We got one last one.
cinnamon.
So Thomas has asked if you guys do the review, do you get extra credit? He has advocated for himself and for you guys, and so I'm willing to make that thing. I don't know exactly how I'm going to do it yet, but there will be, as long as I get, let's say, if I get 70% of people doing the evaluation, I will provide some type of extra credit. I don't know what yet, but I will provide something. Okay. Yes.
You already did the evaluation, so.
Well, so then you're already part of the percentage that's done it. So you're busting up the percentage for us.
But like, why are we making it such a big deal? I feel like it's
pretty simple. 2 minutes of your day.
Well, I mean, some people don't want to do it. So
It's like, I mean, but it's like extra credit. But it's so simple. If you like, just talk nicely about him, talk badly, however you feel.
and I appreciate like the being completely candid and being completely real with the evaluations. But yeah, I've had it happen in the past when nobody does the evaluation. I mean, it just one semester or another, things change for people. So let's I'll sleep on it. I'll let you guys know what I decide to do. But they like as long as I get 70%, and I'm only doing this for you guys, not for my other 126. Like, don't share this with any of them, but
You could increase the amount that we can get back from the exams.
ooh, interesting.
Particularly on.
If you don't want to trace, you know.
Yeah, if I don't want any trace of extra credit, interesting. Okay, I'll take it under advisement. I'll take it under advisement.
When would we know?
Probably by Friday. If you don't get an email from me by Friday, someone send me an email and I'll get back to you guys with what exactly I decide to do. But I'm gonna be thinking about it today and tomorrow and see what I can do to make sure it's not too much of an advantage from the other class, but it's because you guys were willing to advocate. You guys are willing to get more. You guys get more.
I think we deserve it.
You guys deserve it. Yeah. You guys are my favorite 126E class. You guys are my favorite Tuesday, Thursday math 126E class. There you go. Just like I am my mom's favorite younger brother, not her like her favorite younger child's, not her favorite child, definitely not. But so
Like,
I'm definitely child B, and that's okay. I accept it.
You're player 2.
What's wrong with being player 2? You get to play Tails in Sonic the Hedgehog. Okay, we're getting sidetracked. We need to focus. Focus. Okay, so the difference. Hey guys. All right. So the difference we're going to go over now are nonlinear equations, nonlinear systems. So a nonlinear system is a collection of two or more terms where the equation, one or more of the equations is nonlinear. So a 2x4 linear system that we've got here, notice that all the things are raised to the first power. It's all variables being raised to the first power, and they're all basically polynomials in multivariable. Whereas in the 3x3 system that I have next to it, it has an x squared and a y squared. It has notice that there is a linear equation in it, but as long as there's one equation that's nonlinear, it makes it a nonlinear system. So, unlike with linear systems, though, linear systems are very, very nice. It's why we have an entire course dedicated to linear algebra called linear algebra, because they have a unique thing where they either have one solution, no solution, or infinitely many. The reverse of that is not true with nonlinear. Nonlinear, you can have no solution, like you have this circle that does not intersect this line. You could have one solution, you could have two solutions, you could have four solutions, and then this one, it looks like it's supposed to be kind of going off into space, but the intention is that this goes back and forth like this. And so this curve has countably infinitely many solutions. Keep going through each time. There's like at every single it looks like, oh yeah, at every even number, the two curves intersect. And then the other option is that you could have infinitely many solutions where they're both the same equation. Like this one. I know it doesn't look like it when you look at these equations, but they in fact are the exact same equation. So with nonlinear systems, there's a little more nuance that has to happen because we could have multiple solutions. So one way you can do it, and this is probably the best way in the future, now that we have graphing calculators, is to use a graphing system to find it. Now, Alex has its own built-in one, and I'm going to show you how to use it, but you can also check out Desmos's graphing calculator. That one's great. It's a really good tool. So if you don't want to use the graphing calculator on Alex, you can definitely open up a Desmos tab and do that one. This isn't going to be very viable for the in-person exam. If they do throw one of these out, you're going to need to do it by the methods that we talk about in a second. But this is how you do it if you're required to graph it. The first things first is you want to write your equations in function notation, or at least as best as you can. So that is y equals stuff, x stuff. So with this first equation, x minus y squared equals -3. So x minus y squared is equal to -3. I will subtract the x. I'll get negative y squared is equal to -x minus 3. And I'll divide both sides by -1 to get y squared is equal to, leave a little bit of space and then write x plus 3. Like that. Because we're trying to solve for y, so we'll take the square root of both sides. But please remember, if you take an even root of both sides of an equation, whether it be the square root, the fourth root, the 16th root, you have to worry about the plus or minus. That's not the case with cube roots and fifth roots and seventh roots, all the odd roots. They're fine. They don't need the plus or minus. It's because even roots, or even powers rather, they end up having problems with they convert negative numbers into positive numbers. When you square something, it becomes positive. So we have to have the plus or minus there. That gives us y equals plus or minus the square root of x plus 3. And that's going to be two equations. So we have, we'll call it y sub 1, which will equal the positive version, positive square root of x plus 3, and y sub 2, which is the negative version, y equals negative square root x plus 3. So from here, and this will make sense. So we don't go over it in this course, but in Math 127, if you plan on taking that, you'll go over conic sections, and you will start to see that x minus y squared equals -3 is also a parabola, but instead of being a function parabola like we see, which is y equals ax squared plus bx plus c, or in vector in vertex form if you want, these parabolas, as you will see in this graph, they open sideways. And it's because they're functions of y instead of functions of x, technically speaking. So it doesn't pass the vertical line test. It's not a function. So you have to be able to write it in two pieces. That's the only way to get a graphing calculator that only allows you to graph in terms of x to create the equation of it, to create the graph of it. So the other one is much nicer though. So 2x minus 2y is equal to -4. That gives me, excuse me, negative 2x, or sorry, negative 2y is equal to negative 2x minus 4. We'll divide both sides by -2 and get that y is equal to -2 divided by -2 is positive 1x. -4 divided by -2 is plus 2. So our first equation had to be written in two pieces, and our second equation was able to nicely be written in terms of y. Good news. So if we're tasked with using the ALEKS calculator, remember you can use Desmos if you want, if you know how to use it. It's a pretty cool program. But either way, this is me clicking. I've just opened the app. Just opened the calculator. And then click y equals. Their graphing calculator has a lot of good stuff in it, but in particular, its useful thing is doing the y equals. That's telling you to create the equation, to write down some equations. And when you click on that button, it brings up this screen right here. And it says y sub 1, y sub 2, y sub 3, and then it has these little check marks and stuff like that. Feel free to mess around with those things. I believe that might change color, but as soon as you start entering them, it should graph them. Well, so we're going to write y sub 1, that's the positive square root x plus 3, then negative square root x plus 3, and then the last one was the x plus 2. Then click on graph. So now that it has the equations, you can ask it to graph these equations and it will do that.
And it knows that it's two different.
So that brings up a good point. The problem is it views the first equation as two functions. It's the only way it can do it, this graphing calculator. Desmos, you might be able to get away with it, but this graphing calculator, it has to have them in terms of x. So when you graph it, what it will do, especially in this order, it will go, okay, I'm going to create the first graph, which is this one, the positive square root function. That's y sub 1. Then it'll create the bottom half. That's y sub 2. And then it'll draw the third line. Y sub 3. So this is where things get a little bit tricky. Notice that the two intersection points, one of them has to do with the upper half of the first equation, but the other intersection point has to do with the bottom half, the blue curve of the intersection point. So the next thing that you're going to do is you're going to click on the intersect button. If you like, the cool thing about the graphing calculators is they can find zeros, they can find extrema, they can find specific values and all that jazz. But the thing we're mostly interested in is intersection points, because the point of intersection is the solution to both of those curves. Remember, a solution to a system is an ordered point that is on the curve. So for example, 1, 2 is a point on this first line here, and it's a point that solves that equation. So whatever this point is right there, that's the point that solves both equations. Precisely right. It's very hard to tell. It's actually going to be a not nice number. It's going to like, if we were to do this one by hand, which we could do, we'll find out that our answers are not nice. They're going to require square roots and stuff. It's not going to be as nice. So once you click that intersect button, it will pop up with this option where it says first curve that you're selecting, second curve that you're selecting, and a guess point. So you're going to, with this part, choose the curves that intersect. So you don't want to use y1 and y2 because that's a point that's technically on the first equation's graph. You really want to do y sub 1 and y sub 3 or y sub 2 and y sub 3. And then, so once you clicked on those ones, you have to choose a guess point. Now, what is that doing? That's basically the calculator asking you to give it an initial condition. So a calculator, much like with any AI component, right? It's generative AI because it requires you to give it a prompt, right? You have to ask it something so it can create a response. In the same fashion, the graphing calculator needs a starting point so it can run its algorithm to figure out where they intersect. That's what it does. It uses that guess point to start an approximation, and then it will systematically go through a process to get the exact value, or at least up to 99 decimals correct, or whatever it may be. So usually you want to pick, so looking at this intersection point, that's pretty close to 0. So I am going to guess 0. If, so with this one here, I'm probably going to guess x equals -2 or x equals -3. It doesn't need to be perfect. If you really want to, you can even make the guess 9. But the problem is if you use 9, it's going to take a long time for the algorithm to get closer and closer to get an accurate number. So the closer you are, the faster the algorithm happens. Now, granted, with this day and age, we've got some crazy computing power, so it probably doesn't even matter. It just needs a prompt for it. Is that clear? Does anybody have any questions on that? So the guess point is just for you to get the problem started. And then you will click on the find intersection value. And then it will give you the answer right there. And you'll jot that down, or your answer, like jot it down on paper, because it's usually going to be a long, nasty number. And then you'll have to be asked to probably round it to some odd decimal places. Usually says the hundredths. Okay.
Well, that's my guess. That's what happened.
Yeah, probably going to be the hundredths. What's up?
Are those, are those arbitrary, the Y1 and Y3? Could I use Y1 and 2?
So that's a great point. So if I were to do y1 and y2, that's a point that's on just the original top curve. And so it will come up with the answer of -3 comma 0, but that's not the point of intersection between the two different systems of equations. These ones right here, this is this equation. So we don't want to intersect y1 and y2. We want to do y1 and y3. And then to find the other point, we're going to do y2 and y3. So it does matter which ones you choose.
Okay, as long as I have both of them in there.
Yes, as long as you have the two ones where they actually intersect. Yes. All right. And then we'd repeat the process and find this point. But as I said, for that point right there, we'd probably make the guess be x equals -2 or x equals -3. You can even probably just use 0 and it'll still work, but closer you are, the better. Okay? That's all fine and dandy though, but what if you were given what if you were on the exam and you don't have a graphing calculator? That's when algebra comes into play. Here, it's the reason why we've been practicing both of them and why I encourage you to use both is because you can use elimination or substitution, but sometimes both methods work. Sometimes only one works. Sometimes, and this won't happen in this course, but sometimes you need to do something ridiculous. You need to do some weird algebra to figure out how to do it. That's something for an upper division math course to deal with. For us, it's either going to be substitution or elimination or both work. Usually speaking, when both work, one's probably going to be better than the other, but either way. So I'm going to do this one by both substitution and elimination, and then we'll talk about different ones for the next ones.
Trust the process.
Yes. So if we wanted to do substitution, that's honestly the method I would choose because the first equation is already solved for in terms of x. It's already y equals blah. So by substitution, I'm going to rewrite it. You don't necessarily need to, but y equals 2x squared minus 5x, and 5x minus y is equal to 12. We'll take this top equation and we'll substitute that in for x. That will yield 5x minus y, but y is equal to 2x squared minus 5x equals 12. Remember your parentheses so that you don't forget to distribute the minus sign in. We get -2x squared plus 10x equals 12. Now, me personally, I don't like my leading coefficients being negative, so I'm going to bring all the terms to the right-hand side so I don't have to deal with a negative. But either way, I get 0 equals 2x squared minus 10x plus 12. And that factors nicely to 2 times x squared minus 5x plus 6 equals 0. And x squared minus 5x plus 6, that does factor nicely. But if it doesn't, remember you always have the quadratic formula in your back pocket. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Pretty fast at saying that now. But either way, this one does factor nicely. So it's 0 equals 2 times x minus 3 times x minus 2, which gives us 2x solutions. X equals 3 and 2. Remember, it's a 2 there. So by the zero product rule, either 2 equals 0, which is ridiculous. X minus 3 is equal to 0, which is where we get x equals 3. Or x minus 2 is equal to 0, which is where we get the 2. So we don't get an x value of 0 because it's just a 2. So from here, now we can use either equation to find the y value. I'm going to use the bottom equation. So 5 times 3. So we'll do x equals 3. And we get 5 times 3 minus y is equal to 12. That's 15 minus y is equal to 12. Negative y equals -3, so y is equal to 3. So we have the point 3 comma 3. And then we'll also do the same thing with 2. X equals 2. 5 times 2 minus y equals 12. That's 10 minus y is equal to 12. That's negative y equals -2, which gives us y equals 2. So we have, sorry, not -2. No, I jumped the gun. Negative y equals 2, so y equals -2. Excuse me. So we have x equals 2, y equals -2. And those are our solutions. And this will also start to make a lot more sense if we remember what these graphs look like. Y equals 2x squared minus 5x. What is that? Is that a quadratic? Is that a parabola, or is that a cubic, or what is it? What is it? It's a parabola with 0. Like if you factored it, just as an aside, you don't need to draw this, but this is for intuition. You could factor this as 2 x times 2x minus 5. So it has a 0 at 0 and a 0 at 5 halves, and it looks like this. That's y equals 2x squared minus 5x. And this right here is an equation of a line. It's a line with slope 5 and y-intercept 12. -12, excuse me. So what that graph looks like is something like this. It's 5 houses. Yeah, okay. It's not perfect. My graph isn't drawn to scale, but this is 5x minus y equals 12. And we see that it has 2 intersection points. So 2 solutions. The reason why I mention this is if you remember what your curves look like, which is something that you should be able to do with a lot of these things, not all of them. There's certain things that we haven't gone over because they're things that you'll see in Math 127 with conic sections. But if they are relatable equations, you can make sure that you have the correct number of solutions. Because just like with logarithmic equations, there are chances to get extraneous solutions. You should always check your work. And check 3 comma 3 in this equation. You'll guarantee it'll work. Plug in 2 for x and -2 for y. It'll work. I guarantee it. Okay? Any questions on that? If you wanted to do it by elimination instead, so let me rewrite the equations. So as y equals 2x squared minus 5x, and then it's 5x minus y is equal to 12. Now, in its current format, it's very hard to try and eliminate a variable. So I'm going to bring all the variables to the left and the numbers on the right. So we've got -2x squared plus 5x plus y is equal to 0. And then 5x minus y is equal to 12. Now, something to recognize is that with this one, there's no way to eliminate x completely. There's no way to completely eliminate x because you've got an x squared up in the first equation, and there's no way to get rid of it. So even if you are able to eliminate 5x, which that is feasible, when you try and add or subtract them, you'll still have an x squared and a y. You'll still have 2 different variables. So that's the one we have to do. We can get rid of y because it's both y to the first powers. So this is a situation where elimination is possible. However, just for the sake of an argument, if this was y squared here, there would be no way to solve this equation with elimination.
So therefore, by elimination is enough solution.
Well, like if there is no way to do it, you'll have to do substitution instead. Like you'll have to try substitution instead. But that's not the case here. And the good news is these already have the same sign on their y term, the same number on their y terms with opposite signs. So we can add them to add the two together. The y's cancel. And we got negative 2x squared. 5x plus 5x is plus 10x equals negative 12, and so on. I'll explain what I mean in just a moment. Ben, yes.
So if we're doing by elimination,
Mhm.
if it was y squared, why could we not multiply by a variable?
The problem is when you multiply by a variable could be zero, and it could wipe out the entire equation. So if it ends up being a solution to the system, that like you'd be multiplying, and you might get extra solutions that don't actually work. And it can, like, usually it ends up causing more problems than not. So let's just venture on that. That's a great question. So let's venture on that and see what would happen. So if we got negative 2x squared plus 5x plus, and let's assume it was y squared equals 0, and we do this 5x minus y equals 12. If I multiply this equation by y, what ends up happening is now we got negative 2x squared plus 5x plus y squared equals 0. And now we've got 5xy minus y squared equals 12y. So it didn't actually end up giving any, like, solving anything for us, because now I can't even combine the five. Now I've got a 5xy and a 5x and a 12y. Even though the y squareds will cancel, it actually just ends up making it more complicated.
And you'd have to keep doing more and more variables over and over.
Exactly. And the more times you multiply or divide by variables, the more chances there are that you get more and more extraneous solutions, or you end up starting losing solutions, which you don't want.
And ain't nobody got time.
Exactly. No one has time for anything anymore. So that's a great idea, though. And there are certain circumstances where that is like kind of the only way to go. But those are things that you would mostly encounter in upper division mathematics if you were forced to do it. And at that point, there will be other methods that you will learn to how to handle those situations. So, any other questions? And the reason why I said and so on is because you might see this right here is exactly what we had here. So it's going to be the exact same process from here on out. Okay, another one. This one, x squared plus y squared equals 10, and then y minus x is equal to negative 4. This one, elimination cannot work because the first equation is only dealing with x squareds and y squareds, whereas the second equation is working with only y to the first power and x to the first power. So they don't share anything in common. I mean, sure, you might be able to try and square the equation, and that might work. But once again, as we were talking about, it kind of leaves things to get a little bit messy with if you do that. That's kind of like a last resort. So the better option would be to do substitution. And the great news is the bottom equation is a prime candidate for that. You can solve for y or x if you really want to quite quickly. So I'm going to take this one. Y is equal to positive x minus 4. And I'll substitute that in for y up above. That will give me x squared plus y squared, but y squared is now equal to x minus 4 quantity squared is equal to 10. And then please, 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 on the final exam, do not make the freshman's dream mistake. Remember that x minus 4 squared is not x squared minus 16. You have to FOIL it out. It becomes x squared plus x squared minus 8x plus 16 is equal to 10.
So with FOILing, so you do x squared times x, will that be like x power x cubed then?
So are you saying from here, sorry, Are you saying from
Yeah,
here?
if you distribute the x squared to equivalent to the x minus 4, like that.
So it becomes x minus 4 times x minus 4, and we have to do that foiling trick. First, outer, inner, last. And that's where we're getting it. So that simplifies quite nicely to 2x squared minus 8x plus 6 is equal to 0. And you can factor out a 2 again. You get x squared minus 4x plus 3 equals 0. And once again, this does factor nicely. And we get 2 times x minus 1 times x minus 3. Find two numbers that multiply to 3 and add to -4. That would be -1 and -3. And so we get the two x values, x equals 1 and 3. Okay. Now, the question then becomes, what equation do I plug them into? Do I plug them into the top equation or do I plug them into the bottom equation? And the answer is that you probably should plug them into the substitution equation. That would be faster. So y equals x minus 4. But what would happen if you decided to plug it into the top equation, right? What if I did that? With x equals 1, I get 1 squared plus y squared is equal to 10. That would give me y squared is equal to 9, which would give me y equals plus or minus 3. So that's 1 comma 3 and 1 comma -3. So that 1x value gave me two y values. Now this is like we're doing this for a reason because one of those actually does not work. Then we'll try x equals 3. We're going to get 3 squared plus y squared equals 10. That's going to give me y squared is equal to 1, which gives me y equals plus or minus 1. So I get two solutions from this one as well. I get 3 comma positive 1 and 3 comma negative 1. However, if you entered all four of those answers on Alex, it will mark it wrong. Now, on an exam, if that's the case, 1 point off. You did the right concept. You just didn't realize this important thing. X squared plus y squared equals 10. What is that? We remember? 1.2. It's a circle centered at the origin with radius square root 10. So if you were to graph this, this is what x squared plus, that would be x squared plus y squared equals 10. And then y equals x minus 4, that's a line with slope 1 and y-intercept -4. And what that will end up looking like is like this. Something along those lines. Oh, well, actually, let me get it a little more accurate. Like that. And that is x or y minus x equals -4. And so looking at that thing, we should only have two solutions. I know it's hard to read, so let me zoom in a little bit. You should only have two solutions. So we got some fabricated ones. And the reason why we get that is because of the square root. Remember, like as a mathematical object, the second power, it can give you two different solutions. But given context, we can find out which ones don't work. Now, looking at the graph, we can tell that the x values need to be positive, and the y values, it's hard to tell actually what the y values will be unless we graph the perfect one. So we need to test them. We need to test all in both equations. And if you do that, plug them into, we already plugged them into the first equation to find them. That's what we did here. We plugged the x value into the top equation. So let's plug them into the bottom equation to figure out which one works. If x is 1 and y is 3, does that solve this? X equals 1. 1 minus 4 is negative 3. That one does not work. 1 comma negative 3 does work, though. Then we'll try 3, 1. Does 3 minus 4, does that equal 1? No, it does not. That one doesn't work. But 3 comma negative 1, 3 minus 4, that is negative 1, which is our proper y value. So that one does work. So the answer is 1 comma negative 3 and 3 comma negative 1. So unlike with linear systems, because of how they work, because of the fact that we're dealing with nonlinear equations, and the fact of the matter is that nonlinear equations are not as nice as lines, we have to check our work. But once again, as I said, on an exam, if this is the problem that shows up, I'm not saying it is. I'm not saying that there is going to be anything on 4.3. I don't know. I haven't looked at it. But if there were, and you had done this and you had written all the answers, I would mark off 1 point. That's it. Because just like I did with the logarithmic equation problem on the exam 3, remember there was 2 solutions and only one worked. So I only marked off 1 point for that situation. So not the end of the world if you forget it, but you should try to make sure you get it. Okay? Any questions? Perfect time to take our next break. Right? Yeah. We got 2 more equations to hammer out. And that is it. Yeah. We'll take a quick break just to get some stretching done, and then we'll get back into it. People watching the recording, go do like 20 squats or something out of here. So we're back. And so this one, x squared plus y squared equals 16, and 3x squared minus y squared equals 24. This one, you could do substitution, even though it doesn't look like it. And I'll show you what you would want to do. From here, you could write, and so you don't need to do this. I'm going to do it by elimination because it's a perfect candidate for elimination, right? We can eliminate the y value real quick just by adding them together. But you could also say that this means that y squared is equal to 16 minus x squared, and we already have a y squared. So we can just immediately replace y squared with 16 minus x squared, and it'll give us the same answer. So that is a possibility. But I would encourage you to do elimination instead. We'll just add these 2 equations together immediately. The y squareds cancel. We get 4x squared is equal to 40. That gives us that x squared is equal to 10. And that means that x is equal to plus or minus the square root of 10 by the square root property. Now, we can use either one of the equations to solve for y. Now, here's the thing about this one. We get 2 solutions for x, and we'll go ahead and solve. I would recommend using the first equation to solve for y because there's very little that needs to be done. I don't need to like divide or anything like that. It's going to be quite quick. So let's go ahead and do that. So with x equals positive square root 10, we're going to get square root 10 squared plus y squared is equal to 16. That's 10 plus y squared is equal to 16. That gives me y is equal to, y squared is equal to 6. So y is equal to plus or minus the square root of 6. I did that very quickly, so I'll take a step back for a second. You could have used the bottom equation and it would give you the exact same thing, but just solved a little bit differently. And so we got 2 solutions. This one x value gives us 2 different y values. So we have 2 different points. One that is positive square root 10x, or for x, and then positive square root 6 for y, and square root 10 negative square root 6. And I guarantee you, if you plug those into the other equation, it both will work. So we should always check our answers. We should do that, especially with these ones. But these will both of them will work. And then we'll do x equals negative square root 10. And we'll get negative the quantity square root 10 squared plus y squared is equal to 16. But negative square root 10 quantity squared is just positive 10 because it takes any negative number and makes it positive. So you get 10 plus y squared is equal to 16. And by the same argument, y will equal plus or minus square root 6. So we have negative square root 10, positive square root 6, and negative square root 10, negative square root 6. Those are our answers. And you should check them in the other equation to verify. Come on, give me a box. There we go. And both of those, all four of those are the answers. Now, that does make sense, but the problem is we can't visualize it yet because we don't know what 3x squared minus y squared equals 24 would look like. That is what we call a hyperbola. And you'll learn about that in Math 127. X squared plus y squared equals 16. That's a circle centered at the origin with radius 4. And so if you were to graph these things, here's that circle. Center yourself at the origin. There we go. So this is x squared plus y squared equals 16. And okay, is this an upward facing parabola or a downward or a opening left and right or up and down? Plugging in y x equals 0, then y wouldn't exist. So it opens up the sideways way. So it opens up like this. Makes kind of like a baseball. But there's 4 solutions. So unlike the other case, these 4 solutions all do work. And based on the fact of these things being centered at the origin, it makes sense that there's somewhat of symmetry, right? 10 square root 6, 10 square negative square root 6. Negative square root 10, positive square root 6, negative square root 10, negative square root 6. It works out quite nicely. And that's okay. That they can be not nice numbers. Any questions on that? Ben?
Now, what in the second equation makes it not a circle? Because the square, the x squared and the y squared make it.
Excellent question. So why is the second equation not a circle as well? It's because it's minus y squared. That makes it what we call a hyperbola. Hyperbolas are either of the form negative x squared plus y squared or x squared minus y squared. So one of the squared variables is negative and one of them is positive. That's what makes it a hyperbola. Yeah. You will, like, if you plan on taking 127, you will definitely see those probably towards the end of the semester. And they're cool. Not really useful, but for whatever reason, we still teach about it. I'd like us to stop, but whatever. That's not for me to decide. So that's that one. Now the last one is a very, very interesting case. X squared minus y is equal to negative 2, and then x squared plus 3y squared is equal to 9. Now, you could do elimination or you could do substitution. I would argue that elimination is going to be the best option.
How do you know that?
How do I know that? Practice.
Do you know?
Because I've done enough of them so that I know what is going to be easier for me to do. And the fact of the matter is, there is no x to the first power. Both equations only have an x squared. So I can remove that and then all the x variables go away. It's not wrong to do it the other way though. If we want to do substitution, you can just as easily make y equal to x squared plus 2. Bring the y to the right-hand side, bring the 2 over, and you've got y equals x squared plus 2. That will work. That will be fine. But let's just say we didn't see that. And we'll multiply the bottom equation by -1. And we end up with x squared minus y equals -2. And then I'm actually going to move it and have a little bit of extra space. And then negative x squared minus 3y squared. Oh, let's put that in a new spot. Equals negative 9. And we'll add those two together. The x squareds cancel. We've got negative y minus 3y squared equals negative 11. And I don't like my leading terms being negative, so I'm going to bring all the things over to the right so that my leading term is going to be a positive 3y squared. I get 0 equals 3y squared plus y minus 11. Try as you might, you will realize that there is no way to factor this. There are no two numbers that multiply to negative 33 and add to 1. There are no integers that do that. So we have to use the quadratic formula. I'm going to bust that out. By quad formula, y will equal negative b, so negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 3 times c, which is negative 11, all divided by 2 times 3, which is equal to negative 1 plus the square root of 1 minus 4 times 3 times negative 11, all divided by 6. And that's going to be negative 1 plus or minus the square root of 133 divided by 6. Okay, that's not a nice number. And I don't want to plug that into either equation to solve for it in its current format. So my bypass technique is to write a very, very long decimal expansion of it so that I can get very, very accurate. I can get very close. So let's write down the decimal approximations of those numbers. That's going to be approximately 1.755427. Let me write that better. 1.755427. And then the other version, -1, the minus version, is negative 2.08876. All right. So let's try and use those y values in either one of the equations to solve for x. So now that we've done that, we'll do y equals 1.755427. And looking at the equations, I think it would make more sense to use the first equation. Because then I don't have to square that number and write an even longer, more obnoxious number. I can just plug it in and call it good. So x squared minus y, which is 1.755427, equals negative 2. But negative 2 plus 1.755427 gives me x squared equals negative 0.244573. Is that possible? No, there's no way for an x squared to give me a negative number. And even if you don't recognize that right from the bat, you can try and take the square root of both sides. But this is not a real number. Because it's the square root of a negative number. So that y value did not pan out. That's okay. That sometimes happens. Let's try the other one. Y equals negative 2.08876.
Could you
So-
round it up to make it better?
I mean, you can, but if we want, like, so if this does actually give us a solution, it won't. I'll spoil the fun. But if it were to give us a solution, we want to write as many decimals as we could so that we get the most accurate number. so that when we have to like, because what Alex will ask you to do is to like round to 2 decimal places. The more accurate your answer is, the more likely you'll get the exact correct answer when you round. If you round it too early, your answer will probably be off by 0.1, and Alex will probably mark it wrong because it wants the exact form. It usually has like an error bound that it's willing to go around, but sometimes it can be pretty strict. So the more decimals you can, the better. So x squared minus y, but that's what minus negative 0.20 negative 2.08876 equals -2. But that's x squared plus 2.08876 equals -2. And that would mean that x squared is equal to negative 4.08876. And much like before, even though you might not recognize it at first, this is not possible. Try and take the square root of both sides. This is not a real number. And the reason for it, once again, is this piece right here. This negative symbol is the reason why it's not a real number, because the square root of a negative number does not exist in the real world. It's a complex number. So, mathematically speaking, as a mathematical entity, these two things do intersect, but they intersect in the complex plane. They intersect in the fourth dimension. So that is possible, but not in the real world. This is where the milk goes in your freezer when you ask your mom, or the fridge when you ask your mom where's the milk. You look everywhere and you can't find it, and she's able to magically take it out. Right? It's the fourth dimension.
Then she gets really mad at you.
Moms have that skill. They're quite amazing like that.
It's like you don't have to select device.
No, it's literally in the fourth dimension. Women have that capability. They're better than us. And like women can reach into the fourth dimension. It's pretty awesome. Total sorry to get sidetracked. Point is, we tried y equals 1.755. It didn't work. We tried y equals negative 2.08876. It didn't work. So the answer is no solution. At least no real solution. And that would also make sense if we knew what these graphs looked like. I'm gonna come back to them for a second. This right here is the equation of a parabola so that's going to be x squared plus 2. So that's the original parabola, y equals x squared shifted up 2 units. So this right here is x squared minus y equals -2. And then x squared plus 3y squared equals 9. That is not a circle because it's not x squared plus y squared. And like the y squared has an additional constant on it, or coefficient. That's what we call an ellipse. And this is an ellipse that's longer than it is wide. It ends up looking like this. And so this is x squared plus 3y squared equals 9. So as a parabola in the complex plane and an ellipse in the complex plane, these things somehow magically, we can't view it, we can't see it, but they magically intersect in the complex plane. But looking at it realistically on a real line, they're completely separate from each other. They never intersect, so there is no solution. Any questions on that?
Are we gonna have to draw those?
No. And if it is a weird thing, if it's true, like if they were to throw that out there, I would provide you with a graph so you can verify it. So if it ends up being that they throw this, like if it was this specific problem, I would give you the graph and say, instead of solving the question, I'd say, show that there is no solution. So that we can realize there is no solution, we need to come to that conclusion. But hopefully not. Okay? Any other questions? That thereby completes Math 126E. I hope you guys had a good time, or at least tolerated the math. It's been a delight being your instructor for this course. I'm going to miss this class. I'll get back to you guys once again about the evaluation. So as long as 70% of people submit their evaluations, I will provide some form of extra credit or some way to increase your grade. And that's not for me to get cool kudos points on the evaluation. I don't want it to be inflated by positive remarks. I want your honest critiques of the course, what you liked, what you did not like, what you think it could be improved upon, whether it be, and this can also, by the way, I forgot to mention this on the evaluation talk. Additionally, please let me know things that you dislike about the course or like about the course, not just about my specific section, but the material in this course, because that's ways we can look at it. If you guys have something that you really dislike about the course, I can bring that up to my department. If enough of people have problems, and then we can also say like, okay, maybe we should get rid of this topic, or maybe we should teach it in a different way, or maybe we should move it to another course, things like that. Okay? So, I'll start grading these as soon as I can so that you guys have a reflective grade going into the final. Yeah, a little boost, and then I won't be able to provide, so I don't think I'll be able to do the 60% idea because I won't be able to see how many students have submitted it until after finals have been entered. So that's a problem. But I'll think of something. All right, guys, if you have any questions, feel free to email me or come to my office hours. Otherwise, have a great rest of your day. Keep your nose to the grindstone, finish strong. Good luck on all of your finals, not just mine, but especially mine. And avoid the social medias, avoid the doom scrolling, and have a great day and a great weekend. See you next week.